A very good evening, good afternoon, and good morning to all. I, Dr. Pallavi Saxena, SSC member of iLEAPS, and Dr. Samina, Project Administrator, IPO iLEAPS, welcomes you all on the occasion of our 8th talk in iLEAPS Global Colloquium Series 2022. So iLEAPS is Integrated Land and Atmosphere Interactions, which is a global research project of Future Earth. And iLEAPS provides understanding of how interacting physical, chemical, and biological processes transport and transform energy and matter through the land atmosphere interface. So the prime objective of this colloquium is to introduce the scientific society people with the distinguished and significant work of eminent scientists from different parts of the world. It is a very bright opportunity, particularly for early career scientists, to interact with the distinguished speakers and establish the bridge between the ideas and knowledge through this platform. So today, our speaker is from India, Dr. Anuradha Shukla, who is former chief scientist and honorary professor in CSIR, Central Road Research Institute, and ACSIR, Delhi, India. She has more than 34 years of experience in the area of environment and road transport. So this talk is particularly been focusing on road transport, air quality, human health, and policy making. That's a very new area, and how this area contributes to the air quality and the other impacts on the human health and vegetation. And published more than 100 publications in good impact factor journals, books, and book chapters. So she is a recipient of the prestigious Fulbright Fellowship for Environmental Leadership Program and short-term visit to the University of Birmingham. She was deputed to Hungary under International Scientist Exchange Program under Indo-Hungarian SNT Program of Cooperation, and received Indian Roads Congress Commendation Certificate during 79th annual session held at Nagpur, Maharashtra, India, for the paper entitled Procedure for Green Highways Rating System in India in 2018. So she is currently as the chairperson of Committee on Solid Waste Management, Bureau of Indian Standards, and she is also an expert member of Technical Committee on Reduction of Carbon Footprint in Road Construction and Environment, Indian Roads Congress. She was the member of Expert Appraisal Committee for projects related to infrastructure development, coastal regulation zone, building or construction, and miscellaneous projects in Ministry of Environment and Climate Change from 2013 to 2020. So today she will be speaking on what is the impact of road, the emissions from the road transport on air quality and on public health in various Indian cities, and what are the challenges in that, and how can we have a solution, and how can we move forward as a solution, a sustainable solution for the same. So now I will invite Dr. Anuradha Shukla on the floor for her talk. So Dr. Anuradha Shukla, the floor is all yours.
Thank you, Dr. Pallavi. Thanks to Dr. Pallavi and iLEAPS for giving me this opportunity. So good morning, good afternoon, and good evening to everyone joining from different parts of the globe. So the topic of my presentation today is, can you see these slides,
Yes.
Pallavi?
Yes.
Are you able
Yes.
to see?
Yes.
Okay. The topic of my presentation today is road transport, air quality, and public health in Indian cities, challenges and way forward. According to a recent report, this is a new report on air pollution and health in cities released by Health Effect Institute, the Institute State of Global Air Initiative. As per this recent report, Delhi and Calcutta are the two most polluted cities in the world in terms of average annual population weighted PM 2.5 exposures. Mumbai is on the fourth position. So we can see in top 20 most polluted cities, top two are from India. And in another city, another report, according to World Air Quality Report 2020 by Swiss organization IQ Air, out of 30 most polluted cities in world, 22 are in India. This includes New Delhi, which has been cited as the most polluted capital city in the world for last 3 years continuously. Again, the findings were based on the country's annual average PM 2.5. So this is from State of Global Air 2022. We can see here in this graph that from 2000 onwards till this 2019-20, this report has covered, there is a dip between 2004 to 2008-9. So this dip, this is mainly because of that time many regulatory measures from 1996 to 2005, they were taken on fuel quality, on vehicle technology, on alternative fuels and other cross-cutting policy measures. And because of that effect, the pollution levels or PM 2.5 levels, they decreased. CRRI, in CRI, we did a major study on urban road traffic and air pollution in 2002 in major metropolitan cities of India at the behest of National Auto Fuel Policy Committee. This comprehensive study was first of its kind in India to estimate and quantify traffic and associated pollution loads from vehicles and assisted in deriving national auto fuel policy for various cities in India. So the objective was to quantify the emissions and their reductions due to different measures. And we did this study in Delhi, Agra, Kanpur, Calcutta, Mumbai, Hyderabad, Bangalore, and Chennai. So as you can see here, again, this I'm talking of 2001 and 2 when this study was carried out. So 2 decades back, Delhi still was the highest. Delhi had the highest pollution loads, like for all the pollutants, CO, NOx, hydrocarbons, and particulate matter. And then second was, if we see in terms of particulate matter, second was Kolkata again. So same, it remains like after 2 decades, it is same, situation is same. This graph shows the estimated chronological transformation of vehicular emission loads in Delhi, which we computed based on the emission loads from 1996 to 2002. So for PM, we can see with different measures how they affected the pollution loads. Then we did a real-time particulate measurements in different cities from 2005 to 6 using green dust particulate monitor. And again, you can see that Delhi showed the maximum total suspended particulates PM10, 2.5 and 1, and next Calcutta and then Chandigarh. So like now the question is why like so many regulatory measures and control measures were implemented, still if we see here since 2000 to 2020, the like in 2000 the emission weighted particulate PM 2.5 was 100 micrograms per meter cube, and now it is higher than that, more than 100. Similarly for Calcutta, it was 60 and now it is more than 80. So why is it that we are not able to control these emissions in our Indian cities. This may be due to rapid urbanization, population growth, and industrialization. Actually, urbanization is the most complex challenges facing our Indian cities. Between 2001 and 2011, more than 9 million population was added to urban cities every year. And it is estimated that 590 million people will start living in our cities by 2030. And this 2001 to 2011, this was taken from census data, number of cities with population of over 1 million increased from 35 to 53, and share of urban population in them increased from 37 to 42.6%. So actually what's happening is our existing cities, like the urbanization is city centric, which is leading to high densification, stressed infrastructure, and deterioration in air qualities and other problems. So as we can see here, in last 100 years from 1911 to 2011, percentage level of urbanization was from 10 to roughly 30%, like 20% increase. But it is estimated that level of urbanization will be 50% in 40 years, that is by 2050. So you can see the rapid growth of rapid pace of urbanization in our Indian cities. Then the growing urbanization, it leads to faster motorization. With growth of population in major cities, vehicular growth is also increasing, and transport demand is increasing over time. It is characterized by increasing trip lengths, traffic densities, higher energy consumption, congestion, higher cost, and increased atmospheric pollution. With rising incomes, like with economic growth, rise in income, there is a growth in vehicle ownership. So what all this results in choking our city. As you can see, our Indian cities are getting choked with vehicles and leading to congestion. So the traffic congestion in urban areas is due to lack of planning, unregulated growth, heterogeneity of traffic, inadequate mass transit system, growing private vehicles, inadequate infrastructure, and concentrated traffic loads. The negative impact of this congestion is delay, increased fuel use due to frequent idling, acceleration and braking, stop and go traffic, and wear and tear of vehicles. So the challenges the Indian cities are facing is increasing urban population, growing congestion, resulting in rising energy consumption, and thus in deterioration in air quality, increasing air pollution, and adverse health effects. Impact of congestion on estimated pollution loads in Delhi. This was done by us, like in pollution, the pollution loads were again estimated in 2009, and 2002 we already did that study, and then we tried to see the congestion effect. As you can see, for carbon monoxide, hydrocarbons, NOx, and for particulate matter, you can see that with congestion there is many-fold increase in emissions. And then again, we did a study on real-world on-road emissions using portable emission monitoring system for delay and non-delay events. Delay events, I mean, like if a vehicle is stopping at the intersection, or there is a stop and go traffic during congestion. So as we can see in these figures for NOx, CO, hydrocarbons, the emissions are threefold. Mind it, here when vehicle is actually moving on the road, we were monitoring the second by second emissions. Then there is annual fuel loss due to idling of vehicles. Because of increasing vehicle population, it reduces the vehicular speeds. There is a road congestion on the road network, delays at intersections. then vehicles are idling either at congested roads or at signals, and resulting in higher fuel consumption and higher emissions. And we calculated that we lose millions of rupees just because of idling, and the vehicles are idling during the congestion or at the intersection. This study was done by CRRI in Delhi. Then vehicular growth in Delhi as well in other cities, as it is increasing, it, result, it results in deterioration of air quality, as I have talked earlier. And as the cities, they grow in size, vehicular emissions also increase. And if there are buildings on both sides of the road, they prevent dispersion of emissions, causing further pollution. And in developing cities, the most, like in India, the most critical air pollutants are usually particulates, particulate matter, and nitrogen oxides and ozone. The worldwide significant population that live in maximum zone of impact of, major roads, as per Jared from Health Effect Institute. So he showed that, like in Delhi, 55% of population is living in the major, like on the roadsides, in the major maximum zone of impact of major roads. Then Beijing, it is 76% of the population is exposed to traffic emission or traffic pollution. Then we did a study on this was done in 2019-20. We did dispersion modeling using air dispersion modeling software. And as you can see here, for PM10, these are the roads, and here you can see the maximum pollution is there. So since we couldn't do for PM 2.5 because more in this model it was not it was not provided for 2.5, but then PM10 it is heavy, so it settles down, so it is not spreading that far. But as you can see here, for gaseous pollutant, NOx and CO, it disperses fast. Even 2.5, which is light and it is dispersed far off distances, you can see from road, when these emissions are there, they affect a large population staying near the roadsides. So impact of coming to impact of urban road transport, urban air our health, urban air pollution, it is the 13th largest cause of death worldwide. And as we can see here in this picture, that what happens is when we inhale, I'm talking of particulate matter, when we inhale the bigger particles like TSP and SPM and PM10, they get deposited in our upper respiratory system, whereas the finer particles PM2.5 and PM1, they go deep inside our lung, where there is exchange of gases in the alveoli, and they are just PM1 and all, they go to different parts of our body. And since like all these heavy metals, salts, bacteria, viruses, and nitrates and ions, all these, they are deposited on these fine particulates matter. So they go inside, and they may, like, if we have studied even COVID particles, viruses, they go along with the fine particulates in our lungs. So they cause various pulmonary diseases, lung cancer, chronic bronchitis, asthma, and other this pulmonary diseases. So we come to air quality. Air quality is not same as exposure. Actually, what happens when these emissions, they come out of the vehicles, then depending on the number of vehicles and other parameters, they pollute the ambient air, and their concentrations with there are different concentrations and we are exposed to them, and then it is taken inside our body or lungs. Even our fine particulate PM nanoparticulates PM1 less than PM1, they can even penetrate our skin. So the population exposure is governed by type, pattern and timing of the emission sources, then exposure duration, where people are, if they are in road microenvironment, away from the road or roadside or inside vehicle, then, and also it depends on pollutant dynamics. It depends on the transportation mode also, which I'll be showing later. So in the road microenvironment, concentration of vehicle-related pollutant is typically 5 to 10 times higher than the ambient air. And exposure inside vehicles is not well represented by ambient air pollution monitors. The first study which we did in CRRI in 1989 was on effect of air and noise pollution due to road traffic on health of Delhi traffic police personnel. This study was first of its kind in collaboration with All India Institute of Medical Sciences and Delhi Traffic Police, and was widely publicized in newspapers and national dailies and cited by WHO, and this study considered the human health and pollution interplay. So it revealed a significant respiratory impairment in traffic policemen due to exposure to vehicular pollution. And if we found that more than 90%, if I remember the correct figure, it was 93.6% of traffic police personnel who were posted in field for more than 5 years, they had some kind of pulmonary problems. And first time this study suggested the use of mask that time in 1990 by the traffic policemen during duty hours, and we also suggested the rotation of duty. Like if a traffic policeman is posted at the heavy intersection, then his duty after every 3 hours, his duty should be rotated to lesser polluted intersections. And another study which we did, this was in 2019. This was in collaboration with International Institute of Health Management Research, New Delhi. In this study, this was on health impact assessment of Delhi Metro Rail. In this study, the variation in emission loads between with metro scenario and without metro scenario was developed, and it showed the significant increase in emission loads in without metro scenario, and the health economic benefits estimated in Delhi showed that as a result of metro use, a tune of rupees 11,700 millions a year are the benefits in health are the health economic benefits by using this metro rail. Then we also studied the exposure of commuters to pollutant level in different modes of transportation. Like we studied all these, as we can see here, for PM1, 2.5 and PM10, the maximum, the highest pollutant levels were shown by auto rickshaw. So commuters traveling by auto rickshaw were exposed to highest levels of PM10, 2.5 and 1, whereas commuters traveling by metro were least exposed, or they were exposed to least levels of pollutants. Whereas we can see that even two-wheelers, they showed less pollutant exposure to less pollutant levels of these particulate matter, which can be because generally two-wheelers, they are driving at the roadside, they are wearing helmets, and also like there is dispersion of pollutants, so maybe because of that. So least was for metro and highest was for auto rickshaw. the concentration of all, it was also observed that while traveling by metro rail, commuter exposure to levels of pollutants is significantly low as compared to road-based transports and transportation modes. The concentration of all pollutants inside the road-based modes of transportation was significantly higher, and it was dependent on the traffic conditions at the time, flow interruptions at specific road sections. Like if they are at the intersection, waiting at the intersection, then pollution will be more, exposure to pollutant level will be more. Then another recent study, which we again did in collaboration with the International Institute of Health Management and Research, is on impact of traffic on health among school children in Delhi. This study has been completed recently, and the study clearly showed that traffic exposures, they affect the health outcomes, especially when the exposure to residential traffic is considered. And the pulmonary function test, as well as the pulmonary function test, also indicated both restrictive and obstructive effects on the children exposed to traffic. As we can see here, these are various school sites in Delhi, and during the morning peak hours and evening peak hours, the levels of PM2 point was very high. Here in this graph, we can see this is this is the traffic volume, and PM2.5, PM10, and PM1. So it almost like when it correlates with the traffic volume. So all these schools, they were near the major roads or major traffic roads. Then, like, we have seen what is the impact of urban road traffic or urban road transport on our health and air quality. So what are the issues or challenges with our urban road transport system? There is a gap between supply and demand of public transport. Our system of urban transport system is a fragmented system of overlapping networks of public, private, and paratransit. Urban transport studies in India, they hardly consider multimodal system of all complementary modes to provide an integrated system. And non-motorized traffic and walking is not considered while planning. Our Indian roads, cities or roads are planned for either cars and motorized traffic only. If there are footpaths and all, they are encroached or not properly constructed, and the high capacity systems are not implemented at the right time. This I'm saying because, like, Central Road Research Institute, it suggested uh, in Delhi a metro rail transit system way back in 1972, but it was constructed after 30 years in 2001 and 2. So there is lack of integration and absence of hierarchy in public transport network. There is heavy dependence on personal vehicles. Like in this figure, we can see 1/3 of the total vehicles are registered in 23 metro cities, and 45% of total cars are confined to these metros. And personal vehicles use more road space, pollute more, and need less travel demand. Like our roads, if we go on increasing, I've observed we go on increasing the lanes, after some times again they'll be congested, more and more vehicles will come on the road. So that is not the solution. With growing cities, increasing population, and increasing traffic, it necessitates the shift from private modes to public transport. And the ideal modal share of public transport should be around 70%. But in our cities, it's only 35 to 40% in India's metro cities. For example, Like in Delhi, we can see that private vehicles, they constitute more than 93%, whereas this public transport, it constitutes around 3%. So, and buses are only 0.32%. So while personal vehicles, they form 90% of, or more than 90% of all vehicles, bus transport, which meets the need of, which meets over 60, more than 60, sometimes 60 to 80% of the travel demand based on the cities, are only 0.32%. So we need to address this. This graph is from Master Plan of Delhi 2010 2021. Now another Master Plan of Delhi 2041 has come, but this I have taken to show that, like in this Master Plan showed in 2021 the modal split of 80 for public transport and 20 for personal modes. But how far away we are from, we have to still achieve this. And the problem of why there are more private vehicles and people, they prefer to move by this personal or private vehicles, because the lack of suitable feeder service options discourage commuters to shift to public transport. Like if you want to go to metro, then there is a lack of this first and second mile, last mile connectivity. It compels the transit commuters to use private modes such as cars, bikes for public transport connectivity, thereby creating a massive parking demand also. This is another problem. It makes the overall journey expensive, tiring, unsafe, and unpleasant, as we can see here, for transit users. In order to make public transit system more accessible to the commuter, planning for transit systems and feeder services needs to be dealt with in a holistic and integrated manner. So as I said earlier, there is a lack of first and last mile connectivity from your home. If you want to use the metro transport, then like reaching there, there is a lack of first and last mile connectivity, lack of accessibility to public transport, lack of synchronization of facilities using not motorized transport, paratransit system, battery operated vehicles. Then this leads to handicap at interchange points of the public transport networks and commercial hubs which do not have adequate park and ride facilities. This forces people to opt for personalized vehicle usage. So, how can we break the link between urbanization, transport, and air pollution? There is no single strategy for addressing this complex problem. A mix of policy measures best suited for each city's challenges will be needed to improve air quality. Inadequate public transport, coupled with changes in urban form, structure in terms of land use, density of population, concentration of activities, has changed travel patterns. And way forward is there is a need for a holistic, integrated, and coordinated intersectoral approach towards consideration of land use, transport, and environmental implications. Looking at urbanization, current pattern of urbanization is focused on existing cities. So there is a need for setting up smart new cities and development of transport corridors for locating these new cities, new smart cities, which can also be hub for manufacturing and industrial development. So we can't, like our existing cities which are already like developed, we can't go back. So unplanned development can be accompanied by dynamic planning based on growth potentials. Then there is a need for long-term land use planning aimed at the development of integrated communities, combining residential activities with industrial and commercial activities. So right now, our old cities or present cities, they are monocentric. So like many of long distance motorized trips made currently are for work, business or shopping. So if we these could be converted to short distance walk and non-motorized mode trip, encouraging non-motorized modes can be a solution. Then, like apart from technical measures involving vehicles and fuels, regulatory or command and control measures, economic and other measures, a very important measure is reducing the traffic demand. Traffic demand management is very important, and this can be done using the technology such as pedestrian oriented development, bicycle oriented development, or transit oriented development. And in our Delhi Master Plan of 2041, it is planned that transit-oriented development is being planned. Then regulation of transport demand management, parking regulation, mixed land use, then like teleworking, smart choices for workplace and schools. Economic instruments can also be used for reducing the traffic demand, such as fuel tax, road pricing, car charging, pollution charging, polluters pay principle. Then shift, like shifting this, like reducing emissions per unit transported. This can be by integrated public transport system or using the railway. Right now we are more towards the road-based transportation, so we have to shift towards rail-based transportation, public transportation, which is less polluting. Like then regulation like bus tram priorities, non-motorized transport, then for like awareness campaigns, rigorous awareness campaigns, and economic instruments like fuel tax, road pricing, car charges. Then we can reduce emissions per kilometer by using low emission vehicles. Electrical vehicles. Electrical vehicles, here I want to point out that that will be successful only like in reducing the air pollution only when we are using clean source of electricity. Like electricity is not generated by coal power plants. So we have to find clean energy sources for electricity, then alternative energy. Emission standards need to be strengthened, and this low emission vehicle preferential taxes, etc., are few of the measures which can be taken. Then if we come to research part, there is a need for research in middle and low income countries on linkages between air pollution, transport and health. 90% of future urban growth will be in Asia and Africa, necessitating research in this region. This why I'm saying, because like recently this report which I quoted in the beginning by Health Effect Institute, they did studies in more than 7,000 cities, and most polluted cities were from Asia and Africa. And since future urban growth is going to increase in this area, in this regions, it's very important to study the linkages between air pollution, transport and health. And there is a need for holistically addressing the entire spectrum of exposures, health outcomes, and due to transportation. Actually, the research experts, health experts, then transportation planning experts, and our environmental experts, they don't have to work in silos. They have to work together to find the solution. Right now, especially in India, they are working in silos. So it's very important that we holistically address this problem of exposure, health, and transportation. So city transportation is an important pillar for quality of life of citizens in a city. And India needs a balanced focus in terms of improving or extending transportation infrastructure and leveraging smart technology solutions with optimal integration of environment, energy efficiency, and health. Development of guidelines for an health-oriented urban and transport planning so that exposure of people it reduces. And last and most important is science-based policy decisions. So all the policy decisions should be science-based. Thank you. Thank you for your attention. Thanks.